Hi! In episode 13 of Crash Course Physics, it's about statics. Now, statics is admittedly one of the least sexy subjects in physics. However, physics courses spend quite a lot of time on it because it lends itself enormously to the recipe of learning and applying a single principle that spews out equations for calculating. Here, I just want to give a few additional remarks on how to qualitatively understand the static equilibrium of a leaning ladder. Now, the primary force exerted onto the ladder is the force of gravitation, and we know that this force has to be cancelled out because linear momentum cannot accumulate in the ladder. This is performed by the normal force on the resting point of the ladder. Right now, the ladder is in static equilibrium with respect to its linear momentum, but it is not in equilibrium with respect to angular momentum, because the normal force exerts a torque. We know this because if we imagine the wall not being there, then the normal force would cause the ladder to spin clockwise. So this torque needs to be cancelled out as well by horizontal forces. One is the force of friction from the ground, and the other is a normal force from the wall. Now the ladder actually is in static equilibrium to both linear and angular momentum. All the forces cancel each other out, and all the torques add to zero as well. Now, a few remarks on deformation. The two regimes of deformation have been shown, the elastic zone and the plastic zone, as well as the point of fracture. And I just want to show you how this behavior comes about by understanding that the material is composed of atoms forming bonds. If a relatively small tensile stress is exerted, then the displacement spreads itself evenly among all the bonds. And if the tensile stress is relieved, all the atoms revert back to the original position. This is the elastic zone. If the outside force is strong enough, then the atoms actually rupture their bonds with their next neighbors and form new bonds with atoms that are further apart. Now the actual shape of the material is changed irreversibly, and we are in the plastic zone. Deform the material enough, and the atoms actually find no more other atoms to form new bonds with, and fracture occurs. So I hope you enjoyed this little nitpick for this episode of Crash Course Physics. Don't forget to subscribe and follow me on Twitter. See you next time.